Hey guys, let's start today trie data structure. So in trie data structure, the structure will be for trie is something like this. You will have one character array of size 26, okay, and means trie node array of size 26, where trie node is the our trie itself, okay, and then one is and flag, boolean flag, so which whose value would be true or false, which will tell us whether the string is getting ended here or not. So we will use try to store the string value, okay, character wise. And so in one node one character will get stored, not one character, actually you will have a 26 size of array, so you can store actually 26 character. And now, so here we will see insertion in a trie, okay, insert, then search, and then start with, okay. This three operation we will check here. So let's take one example, okay. Let's say if I wanted to store a double p le, this is one string, and second is a double p, okay. You need to store these two strings in a trie. So first see the trie structure which I just described, right? You will have a character array trie node, okay, of size 26, and then is and flag whose initial value will be false. Okay, now you need to store a double p le. So what I will do, I will first create one trie node, okay, and a, now I told you that its size will be 26. Why 26? Because English has 26 alphabets, okay, and because this is array, so it will start from 0 to 25. So 0 will be a, 0 will represent a, b, for b 1, okay. So just do -1 for each characters. You need to store a. So you will go here and check in its try children array if children 0, okay, a is representing 0th location, so children 0 is empty or not. No, it is currently it is empty. So what you will do, you will create one one trie node, okay, is and will be false, because you will put it true when once your string is completed, means after e we will put it, okay. So currently it will be false only. And then it at children 0th location, okay, so here you will add a, and at children 0th location you will add its reference. Okay, now it's time for p. So after a, p should come. So first you will go to a, okay, you will see the reference, so you will come here, then you see, okay, a is here. Now it's time for p. So you will check in this character array, in the second node's character array, for the children of pth location, whether it is blank or not. It is blank, so what you will do, you will create one array again. This one will be false, and then we'll store it's a children p for the children index equal to p, okay, associated index for p. And then you will put the reference of this one also. Now again a and p is done. Now again p, okay, so you come here a, p, okay. Now it's time for p again. So you will create one children array here also, and it's a children pth location. You will put p, and then again f. Now l, so same. So you understand, right, why we are putting this a, p, p, l in this new nodes, and we are why we are connecting it to previous one, because your string is something like this. L should be stored after p, okay. So we are coming in a sequence. So now it's time for e. So now here what will happen for e will get stored, and here t will come true. So you will come to know when you will revisit that here the string is getting completed. Now it's time for a double p, okay. So a p p, you will go here, you will check its 8th location, okay. A, no, it is not empty, so you will come here. Now you need you will check this tree node's children, okay, to pth location, whether it for this p whether it is empty or not. No, it is not empty, so you will come here. You got p also, right? Now it's children array, you will again check the pth location if it is empty or not. Yes, it is not empty, so again you came here, but your string ended, right? So you will mark it to true. So this is how in the same memory location you have stored two strings. So similarly you will store all the strings, okay. Now let's see. So this was the insertion part of the array. So I'll do one thing, I'll take this entire diagram here, because we need to see our code here, right? Okay, now here if you see what is happening in insertion, okay, what is happening in insertion here, in insertion you will get the word, okay. So now as I told you, you get as a string, and then one by one word you store in a trie node. So for that you need to convert that word to 2 character array, okay, and one by one you will take that index ch, and you're doing minus a, okay, ask to get its ASCII value, like whatever is ch, you will minus a's ASCII value, so you will get that particular index, okay. Now this is normal, you can do that. And then initially you will assign one trie node, okay, and it will point to root node. So now root node is actually, this is global variable where you are initializing it into the constructor, okay. So new node, so this one we are talking about, this one, this is root, okay. Now you will get you will iterate that character array, okay, for each like a, p, p, l, and then you're checking if node ka children ka index, if node's children index of that a is equal to null. If it is null, then you will create new tree node, right? It's also a trie node. So you have created one trie node and you assign its a reference to this children index, okay. Now and then like in binary tree, binary search tree, what we were doing, left equal to left right, then you move to another direction, right? So that is how you need to do. So that's why you're doing this node equal to node children dot index. So you will come here node equal to, so whatever reference is stored here, you will come to that reference. So here you will come, okay. Now for the next element, again you will create one trie node and then assign its a reference to its a children index, and then a node will point to this one. That is how you will go and insert each characters. Now after done with your character insertion, you will put node dot isAnd equal to true at the end, okay, after this for loop. So this is how you do index. Now if you need to search something, so how you search it in a trie, very simple. Let's say I need to search a, p, p, l, whether this exists in a trie or not. Actually this doesn't exist. Why? See, you have a, p, p, l, but if it's is and you check it is false, it means that this word doesn't exist in a our trie. We have apple and app, okay, but not appl. So see, appl, what you will do first, you will convert this into two character array. You will take each character, okay, minus a to get its index value. Then you check its reference, okay, a is there, fine, p is there, okay, that is also there, p is there, l is there, and then once your string is completed, then you will check its is and flag, that is false, means that word doesn't exist, okay. That is what we are doing here in this search function. First you will get one node which is pointing to root. This time root is not empty, you already have some values, okay. And then you will convert, this is your for loop, okay. You will convert that word into two character array. Each word you will take and you check if it's node dot children dot index equal to null, to return false. Because for example, if I'm searching a and I don't find here a, let's say b is there, I don't find a, it means initially only I at initial phase only I came to know that that word doesn't exist, so I'll return false. Otherwise I'll go to that direction, node equal to node children index. I'll go to this direction one by one and check. Once I'll iterate all the character from the word, I'll return node dot isAnd. If it is false, means that doesn't exist. If it is true, then that means word exists, okay. Now you need to check starts with, okay. So for example, I want to check all the words which starts with ap, okay. Let's say I have a word like appl or ap, okay. In that case, what you will do? Nothing. You will come here, you will move to this direction. First you check the a, then p, okay. So and once your string is completed, okay, you just return true, because you doesn't care that whether the isAnd is false or not, because you're not searching for entire word. You're searching if the word is starting from a and p. There could be anything, there could be empty also, there could be any other words also after ap, but at least you have ap, okay. So that is what we are doing here. See, all the code is similar only, okay, for searching, insertion, everything. So you're doing same thing only. First you're assigning node to root to node, and then you're iterating your word and getting the character one by one, and then checking node dot children index is equal to null. So at the first only you came to know that okay, a is not, so for example, if you're searching for ap, you got a, but p is not there, so it means that you don't need to process further, right? And you came to know that okay, this is the, you don't have that word. Otherwise you go to this direction, node equal to node children index, okay, and then at the end return true once your string is completed. So that's it, and this is your main method. So we have inserted apple and app, and then we were checking for apple, so you will get true. You will check for app, you will again get true. You don't have apple appl because it's is and is not false, is not true, okay. Then ap, it starts with ap, you will get true, but bat you will get false. So that's it. Thank you.